Hello everyone, welcome to a new session. So in this session we will study merge sort algorithm. So merge sort algorithm is based on the divide and conquer technique. It divides the array into smaller parts, sort them, and then merge them back together. Example, so here we have an array. Let's see how we can sort this array using the merge sort algorithm. So as you see here, it says it sorts based on divide and conquer technique. That means first it divides the array into smaller parts and then sort the smaller parts, and at the end merge them back together. So let's see how we can do that. First of all, here you see we need to find the middle element in order to divide it into two parts. So how we can find the middle element? We take the length of the array and divide it by 2. So that gives us the middle element or the middle node. For example, in this array, so we have 1, 2, 3, 4, 5, 6. The length of this array is 6. If you divide this by 2, the result would be 3. That means before element 3, one part, and after that another part, and we keep this division until there is one element left in the array. Let's see how we can do that. So when we divide this, it is 3. So we say that from the we take a slice of this array from the first element until that middle one into the left side, and from that middle one to the end we put that in the separate array, and we call it right array. For example, like this. So if I divide this one, the left array is so from the first one up to the middle one. The middle one was 3. 0, 1, 2, 3. And you know that in Python, when you take a slice of that, when you specify a range, it includes the starting point but exclude the ending point. For example, here in this range, when you say from the first element up to the middle one, that means it includes the first element but does not include the stopping point or the ending point. It comes until to the one node before the middle one. For example, middle is so 0, 1, 2, 3. 0, 1, 2, 3. Middle is here, the index 3. And when you give it to the Python, it considers only until its before element. So we take 12, 11, and 13. So it is our left array, and the rest of them from the middle one to the end, right, from the middle one. So we said from the middle is 3. We said it takes the starting point is middle, that is 5 up until the last element, 5, 6, and 7. So, and here we keep calling this method recursively to keep dividing this array into two parts until there is one element left, and that is, we check here the base case. We say if len array equals or less than 1, return. So until there is more than 1, we keep dividing this. So let's keep dividing them. Now again call it merge sort and divide the left part, for example. So we divide this to the two parts. The left, so again the middle here, 3 divided by 2, that is 1, and so we take from the first up to the middle one, which is 1 in the left array, let me copy this one, that's easier and faster. So left, so we take from the first until the middle was 1, and I said it exclude the ending point when you take a slice of array using an arrange. So it only takes 12, and now the rest of them right equals from the middle up to the last. So the middle is 11, from 11 up until the last element, 11, 12, 11, 13. So here when we check this one now, it says the length of this array is 1, so it returns, it stops division, but here it still keep the division. So again, it is the left one, the left one is 11, and the right one is 13. So now you see here also the length of the array is 1 and it returns. So we keep dividing them until the size of the array was 1. The size of the array becomes 1. So we do the same thing with this part of the array, with this branch. Again, we keep dividing them. Okay, so here if we divide this array, the size of the array is 3, and 3 divided by 2, that is 1. So that means from first element up to the middle one, which is 6, we take in the left size. So let me copy this one. So we take number 5 in the left one, and from the middle one up to the end, we take into the right one. Which is 6 and 7. So here the size of the array becomes 1, so it stops dividing it anymore, but here it continues one more step. Okay. The left is 6 and the right is 7. Okay, so we made all the division. It is how merge sort algorithm works. First we divided it into smaller arrays until the size of the small array becomes 1. Then we arrange them, merge them in a sorted way. So for this, for the merge part, we need to have a separate method which is helping us. So in this merge sort, we start from the very lowest level up to the highest one. For example, first we sort these levels, then those level, and then this level, and after we merge all of them in a sorted way, that means we get this array sorted. So how we can merge them now? So we define a new method and in this method each time we pass the left size, the left array, the right array, and the array itself. So and when we pass this to the method, so we keep comparing first element of the left one to the first element of the right one, and whatever element is small, we take that into the array and put that in its right location. So here of course we need to know the size of them. That helps us to iterate or go through or traverse the array. At this point they have one element, it is easier, but when we merge them here, for example, at this time there are two elements. For example, at some point we have to merge this one and this one, so we have to be able to traverse all the elements in this array. Or for example, when we merge these two and at this level, we should be able to traverse all of them. So for that reason we need to know the size of them so that we can traverse based on the size of the sub-arrays. So each time we get the left size from the left array and right size from the right array, and then here we need some iterators or indices, and then we start comparing them. At this level it is easy because there is only one element, so you just compare those two and you say, for example, so I have started comparing them from the left one, so let's start first the left branch. So first I check 11 and 13. I say as far as L, the index of left array, is smaller than the left size, than the size of the left array, and right index is smaller than the size of right array, we have to keep traversing the array, because here you see you have two arrays that you compare. One of them the left array and the right array. That is why we have left array and right array size. So we say that if left array at index left, which is 0 at this point, is less than right array at index of r, which is 0, for example these two, we compare 11 and 13, and we say if 11 is smaller than 13, so that means 11 should be first and 13 should be later. Here by accident it is already being sorted, but there is not always the case. So in case it was the reverse way, so you would put 11 first. You could say that array, which is this one, at index 0 should be the smaller element, and we said if 11 is smaller than 13, so we put that in the index 0, and we say L plus plus the left index. For example, if there are more elements, so we took the first element and we put that in the right position in the array, so we need to check its next element, but right now there is only one, so it doesn't make sense, but you will find out in the higher positions, in the higher levels, when we are here, for example. Or if it is the other way, if the left element is greater than the right element, that means the right element is the smaller one, so we put this in the first index. So we say that at index 0 the right element should be put, and then we put right index plus plus. That means if there are more elements in the right array, so we took the first one and now we need to go to the next element and compare that one, and after we check both of them, then we need to update the index of the array also, so we make the index of the array plus plus. So now when here you checked, you said if L is less than left size, yes it is, and right, yes it is, so that means the condition meet. and you check here this if left array at index L, that is 11, is smaller than the right array at index R, that means number 13. So this condition met. When this condition meets, so you put the smaller array in the smaller element in the array. So you take the index of this array, we say index 0 should be put the smaller element which comes from the left array, that is this one, and we make it plus plus. We increase the index because if there is more elements, so we should be able to go to the next one. So when you do that, there one interesting thing happens. So now the if executed and the while loop continues. This time when it comes here, it checks is L less than left size. Left size was only 1, and you have increased the L from 0 to 1. Now it is not less than the left size. That means this while loop does not execute, and the problem is that you just put number 11 in the array here, but you have not put the number 13 in the right position yet. It is left. So that is why we need another while loop just for the cleanup in case this scenario happens. So we should be able to go through that elements separately. So we say while R is less than left size, yes, at this point, for example, R is 0 and it is right size is 1, so 0 less than 1. So we say that array I, when we add it in the array this element, we increase that by 1. So now when we say array I, that means at index 1. So we put that in the index 1, there's right array from index 0, and we increase the index of the right array in case there are more elements, and of course we need to increase the index of the array itself also, because if you put number 13 here and if there were more elements, so they should be put like in the next index here in the array. So now we are done with this merge. Now we are here. So here you merge these two. So come to the merge part again. In this part, the left array is 12 and the right array is 11 and 13, and the array itself is 12, 11 and 13. So again you need to go through each elements in these arrays and compare them. So here you say if the first element in the left array, which is 12, is smaller than the first element in the right array, put that in the first index of the array. So you check that, you say while the left index is less than left size, of course at this point L is 0 and left size is 1, so it is less than that, and R is less than the right size, and of course R is 0 and the size is 2, so the condition meets. Then you compare these two elements, you see which one is smaller. You see that the smaller node, the smaller element is in the right array, so you take that smaller array. So this condition does not meet, you come to the else part, so you take that element and put in the index 1, index 0. You take number 11 and put here. You put number 11 in the index 0, in the index 0 of the array, and then you see here you need to, because there is one more element, so that is why we have increased the index R by 1. So that means next time it should compare number 13. So when we added that also, when we increase that at the end, So now this index 0 in the array is filled. So next time when we compare these two, we should be able to add the new node here, the new element in this index. So we have to increase the index of this array also. So we say index increased by 1. So again it checks, is L less than left size? Yes, still it is 0 and it is less than left size. And R is 1. Is 1 less than 2? Yes. So again this condition meets. So if the condition meets, then we come here inside and we compare number 12 and number 13. So number 12 is from the left side, from the left array. From the left array at index 0, is it smaller than right array at index R? Index R is 1 at this time. That means number 13. And this condition meets. So if this condition meets, that means number 12 is taken here. So in the array at index I, which now increased by 1, which belongs to this one, so we put here left array from index L, which is 12, and increase it by 1, just in case there is more elements. We need to traverse through the whole array. So when you increase it, you come out of the if block and you increase the array index also, then the while loop continues. So at this point, when the while loop continues, so the next element should be coming here. At this point, L is increased by 1 and size of the array was also 1, left array. So this condition does not meet. So what does this mean? This means we did not put number 13 in the array yet. So again we come here and it is from the right array, so this one is executed because this one already does not execute. It says L, is it less than left size? No, L is 1 and left size is also 1, so it doesn't execute. We come to this one. Is R less than right size? Yeah, R is increased only one time when we added number 11 here, and the right size is 2, so it says yes, 1 is less than 2. So now we say, well, at index I, which is this one, because we had increased that here, we should put the element from right array, which is number 13, at index 1. We take number 13 and put that here, and we increase the index of right array just in case there is more elements, and the index of array also just in case there is more elements, so we should be able to put in the next index. So now at this time when it checks this condition, so R is now increased to 2 and 2 is not less than 2, so that means this loop is not executed anymore. So we have sorted until this part. We do the same thing with the right branch. So first we check these two, the same as this process. So you compare 6 and 7. So 6 is smaller, so you put 6 first and 7 after that. Then we compare this list with this list. So first compare 5 and 6. 5 is smaller, put 5 here, and then 6 here, and then 7 here. So now you have two sorted array at this level. And now you put the element of these two sub-arrays in the right index here in the main array. So you compare the first element of this with the first of the element of this. So let's keep track of that also here. So at this point, when you say while L is less than left size, of course left size is 3 and L is, the index is 0, it is 0 less than 3. Also R is less than 3, 0 less than 3. So you say if, you compare 11 and 5. You say if left array at index L, which is 0, which is number 11, is less than right array at index R, which is 5. So that condition doesn't meet because element is not smaller than this. So we go to the else part. If that doesn't meet, that means this one is smaller than this one. So we automatically take number 5 and put in this index. So we put number 5 here. So we put number 5 there from here, and we increase the index of right array by 1. So we took number 5, and now we come here, and also after adding the 5 here, so we have to increase the index of this array also, so that we should be pointing to this location now. So now we compare 6 and 11. Because L is still 0, we did not increase that. So now again 6 is smaller than 11, so we put that here and increase the right of the index by 1. When we did that, we increase the size of array as well, so that means the next element should be put here. So now we go to the third element, 7. Again we compare 7 and 11. Again we see that 7 is smaller than 11, so we put 7 here and increase the right index by 1, and also increase the index of this array also to point to the next location. So at this point, when we check, L is less than left size, of course, because L is still 0. R is at this time 3, because we increased that here, and 3 is not less than 3. So that means this condition, this while loop doesn't execute. But you see, still there are elements left in the left array. So that is, we have a cleanup part. So now it checks this one. If it is not executed, of course it go to the next one. So we say while L is less than left size, L is still 0, and it is of course less than 3. So then it takes the first element, which is 11, left array by index L, and put this in the array I, which we had increased that earlier, and that was pointing to this one. So we put number 11 here, and then increase the index of the left array and the index of the array itself. That means now the array points to this location, and we go from 11 to 12. Then we put number 12 here, and then we increase the index of left by 1, and also the array also by 1. Now the array points to this location. So the next time when the while loop checks, L is still less, L is 2, and it is still less than 3. So, and we left array at index 2, it is 13, so you put 13 also here, and increase L by 1. So at this time when it comes again, now there is index is 3, 3 is not less than 3, and that means we have checked all the elements in the array, and now we have a sorted array. So I hope it was clear enough. Still, if any part is not clear in the code or in this diagram, you can ask them in the comment section, and I will take care of your questions. Until the next session, have a nice time.